All right, that didn't take too long. So now, what I was saying before, the stuff that we learned earlier about graphing, we're going to put into practice again today. It's not really that hard if you know how to if you know how to take something that's y equals mx plus b and graph it. You shouldn't have too much of a problem with doing this. But we're going to do something a little different. We're going to get a little more practical with the graphing. You're also going to have to know a little bit of algebra to get our equations into the form y equals mx plus b. We're going to have to do a little manipulation, a little stuff to it to get to that point. So we are going to do some algebra. We're also going to include some graphing with it. The graphing is probably the easiest part of this whole entire thing, or even though it says solve by graphing. So what I'm going to do is I'm going to write, they call this, I didn't write this down here. Most books do this, but this book doesn't. They call it systems of equations. They do refer to it, but they usually like title the lesson or something, systems of equations. So it's not order of operations. It's completely different. Okay, so basically what it is, at the beginning anyway, we start with two equations. Okay, you eventually branch into three different equations, but we're not going to do that in here, I don't believe, at least not for the first part of this chapter. What we're going to do is we're going to look at two equations. Both of them are going to have x and y in it. All right, so let me write the equation. Let's talk about how to solve. And the one way that we're going to solve for it is by graphing. The next time, I don't know, yeah, probably tomorrow, we'll get to 3.1b, I believe. Actually, this 3.1, I don't think it's A and B. I think the 3.2 is going to be an A and a B. So forget the A. This probably depends on if I finish or not. But anyway, my goal is to finish 3.1 today. All right, so here we go. I'm going to write down a system of equations. So basically what that means is you're going to just have two equations. Both of them have the same two variables. In this case, it's x and y. It could be other letters, but for the most part, high school algebra, we always stick with x and y. Right, we put a little bracket here because that just shows that they kind of go together. So the x in this first equation is the same exact number as the x in the second equation. Did you hear what I just said? So the x is the same. So if x is 3 in the first equation, it's going to be 3 in the second equation. It's not just two random equations with different values for x and y. Okay? That's why it's a system of equations. They go together. That's why you put this little bracket on the end of it, or brace. It's really a brace. That's why you put that there, to show that they go together. So whatever you get for x works for both of these equations. Guess what else might be true? Whatever you get for what? For y is the same for both of these equations. All right, so whatever you get for x works with this. Whatever you get for y works with this right here. Everybody understand that? Here's something that I actually just taught one of my geometry classes, that we weren't doing this stuff. We were doing some stuff with graphing. Actually, we were doing something else. It doesn't make any difference. But we did have a situation where we had two equations with the same variables. Okay? We just finished doing that in there. This is something that I don't believe, maybe I was taught this, I just can't remember, all right? But I do remember when I was in college, taking some early math classes in college, that the professor said, if you have two variables, you must have two equations to solve for both of those variables. You hear what I just said? That's important. It really is. I don't ever remember hearing that until I got to college. But if you have two different variables, all right, x and a y. If I just had this by itself, could I get x by itself and just have a number? Could I say x is 3 or x is -7 or something like that? No, there's no way, because I don't know what that y is. Agreed? Now, we have done some substitution in here, haven't we? Remember, did that f of x stuff where we put a number in for x and then we just multiplied it, added it, whatever we had to do to it. So we actually have done some things called substitution. We're not going to do substitution today, but we will do that in the next day or two. All right. So, but this right here, you can't just get x by itself just with that equation. You can't just get y by itself just with that equation. So what you need is another equation, right, with an x and a y. And then you can put them together. You can do stuff to put them together to get a value for x and get a value for y. We will eventually do that substitution and elimination, which you've probably done since Algebra 1. We did a slight little bit of this in geometry, and then You probably did quite a bit of this in Algebra 2. You probably remember this at least from Algebra 2 if you didn't have it in Algebra 1. Okay, enough of that. But I'm going to teach it to you as if you've never seen it before. But that's tomorrow. Today, what are we going to do? We're going to solve for x and y. Okay, and that's what this thing says. It says solve. Well, actually, usually they put it out here. They say solve the system of equations, or they just say solve. In this case, we are going to solve one particular way. I could do this another way, but since I'm learning solutions by graphing, guess how I'm going to solve it? Solve by what? By graphing. Okay? So what I'm going to do, let's get rid of this. What I'm going to do is take both of these equations and I'm going to graph both of these equations. But before I graph them, are either one of these set up y equals mx plus b? No. So that's what I'm going to do first, right? And we've done that, right? We just spent quite a while talking about how to do that. So let's take that first equation and let's put it in. What is that form, by the way, the name of it? Y equals mx plus b. Slope-intercept form. Good. Okay, so you were listening. That's nice. So we want to get slope-intercept form. We want it to look like y equals mx plus b because it's a lot easier graphing if it's in that form. Okay, so that's what we're going to do. We want to get this y by itself. So what's the first thing I'm going to do? Subtract the x. That's right. I'm going to get rid of the x, and then I'll divide by 2. So let's do that step first. So let's do it over here. So I've got, keep the 2y there. What am I going to do? Subtract an x. So that x will go, right? It'll cancel out. Am I going to go 4 minus x, though? No, I want to go negative x what? Plus 4. Okay? It's the same thing, isn't it? 4 minus x and negative x plus 4? Sure. And now I get y by itself, one little step, divide by 2. So divide this by 2, divide this by 2. And what do I get? I get y equals, what's that? What's the coefficient? What's the number in front of that x?
1.
It's a 1. It's a negative 1, technically, right? So how would I write this? I would write this what? Negative, no, not negative 2x. It's negative 1 over 2. The 2's in the denominator. So I can't say negative 2x. It's negative 1 over what? Over 2x. So it's negative 1/2. That's what that is. Plus what? 4 over 2. It's 2. So can I graph this? Can you graph this? This is actually a better question. Can you graph this? Yeah, you should be able to. Put a point at 2 on the y-intercept, and then my rise and run is negative 1 over 2. Plot the 2 points, connect the lines, and you got a line. We'll do that in a minute, okay? Everybody with me so far? So we're going to graph that in a second. But what do I need to do now? I need to get this thing into y equals mx plus b in a slope-intercept form. You can do it a couple ways. You know what I would do? I would add a y to both sides just to keep it positive. Now, some of you might think, well, let's just subtract a 2x like I did up here. Yeah, you could do that, but then you got to get rid of that negative 1. It's really not that big of a deal, but some students have trouble with that. So if I was in this situation, to me, the easiest way to do this is just to add a y, put it over here, and then get rid of the 3. How would I get rid of the 3? Subtract a 3. So eventually, what would I end up with? You can almost do this in your head, right? Add a y, comes over here, that's a plus y. Subtract a 3, so what's y equal to? 2x minus 3, okay? So that's my other graph that I want to put on graph paper, okay? I want to graph both of those things right there. Everybody with me on that? And that should be easy to graph too. Wouldn't you agree? Yeah, negative 3 is the y-intercept. The slope is 2 over 1, right? Rise 2, run 1, and then you got a graph. I'm going to put both of these graphs on the same graph, okay? They're not two separate things because they go together. Tell you what, let's do this. I hope I didn't hear a phone. Heard something dinging. Maybe it was just somebody's brain and stuff was kicking in. You're like, oh yeah, I got it now, and your brain dinged. That would be good. That'd be good for a teacher anyway, right? Somebody understands something, then I hear this dinging noise coming from your head. Actually, I heard, I was teaching my geometry class the other day, and this, I got like 3 girls that just came in like a week or 2 ago. All right, I'm not going to tell a story then. Because you don't allow me to. You just don't. And he doesn't even realize it. So, no stories for you. It'd be nice if I could teach this like a regular class. It would be. But you guys are still talking. Don't get it. All right, whatever. Here we go. So what I'm going to do is I'm going to graph both these lines, and we're going to look at both those lines, and we're going to come up with a solution. Remember, the whole idea, what was the whole idea behind this? It wasn't just to graph it. It doesn't say just graph it. What does it say? Solve. So I want to find what x is equal to, what y is equal to. How in the world am I going to do that? By graphing a couple lines. Any ideas? Let's graph these. Let's graph this first one since we did that first. The y-intercept is 2, so 1, 2, right there. And then the slope is negative 1 over 2, so I could rise negative 1, means I go down 1, run 2, 1, 2. Now look, just to make this a little more accurate, I think I might have mentioned this one, maybe 2 times at the most, but, and some of you saw this when I graded one of your quizzes or tests or something like that. I think it was a quiz because I haven't given you the test back. But look, you could do this, but sometimes drawing a straight line, when those points are so close to each other, sometimes you're not super accurate because your ruler could either like move up or down just a little bit, and it still looks like it connects them, but it may be off just a little bit. So here's what I can do. I went down 1 to the right 2. So let's do it a few more times just to get more accurate, okay? Down 1 to the right 2. It's not hard, is it? Do they still line up, make the same line? Yeah, absolutely. So let's down 1 to the right 2. Let's do it one more time. Down 1 to the right 2. Let's do this. Instead of going down 1 and to the right 2, what are we going to go? We could go what? Positive 1 over what? Negative 2. Isn't that the same thing? So watch. I could go up 1 and to the left 2. See how it still lines up? Why do I want to put all these points in here? It seems ridiculous, but just to make it more what? What did I say? More accurate, right. So let's do it a couple more times. 1, 2. It's easy. It only takes a couple seconds. 1, 2, 1, 2. All right, there we go. Everything lines up perfectly. Let's connect from here to here. That way, I'm going to be a little bit more accurate. Now, when you're doing these homeworks on your paper, you may not be that accurate, but see my graphs? I don't know, can you see that right there? See my graphs right there? I just did it on blank paper, don't even have any line paper or anything like that. But what I do is I get a ruler, okay, and I actually make the little marks in between each one. I make them the same. You don't even need a ruler. You could just get a piece of paper and get 2 points and just go mark it once, move it over, mark it again, move it over, mark it again, okay, to be more accurate. So the thing is, accuracy is really important here. I really, on that last quiz and test and all that kind of stuff with the graphing, I let a lot of stuff go. I mean, I looked for certain things that you needed, certain points that you needed plotted, but some people were more sloppy than others. This situation right here, you cannot be sloppy. You cannot be inaccurate. You have to be accurate when you graph this. That's why I pulled out the graph paper and I just didn't draw an X and a Y axis, okay, and just start putting my lines just anywhere. So if you have graph paper, this would be the time to use it. I was thinking yesterday, and I should have done that. Maybe, it's going to be too late now. But anyway, I was thinking about maybe printing out like a paper with maybe 5 or 6 graphs on it, just to make it a little easier for you. Maybe I'll do that. Maybe by the end of the day. If you really want graph paper, come to me and I'll print out some. And because you want to be accurate with this. That's the whole key to this, all right? Because if you're not accurate, you're going to have a wrong answer, all right? So let's do this one right here. Let's do this in a different color. Let's go yellow. All right, let's graph this one. The y-intercept is negative 3, so it's 1, 2, 3. Put a point right there. The slope is 2, or 2 over what? What's the run? It's 1, right? Rise 2, run 1. So what do we do? Rise 2, run 1. Watch this. Rise 2, 1, 2, run 1. Check this out. What happened? They intersect each other, don't they? And they intersect each other at that particular point. Well, it doesn't mean they're, well, they actually are perpendicular. We're not here to learn that, but you're absolutely right. I could have told you, I didn't even think about it until you said it, but I should have, because I just finished teaching this to my geometry class. They are perpendicular to each other. Not just because it looks like it, but because if you look at the slopes, did we do that in here? I don't think we did. Did we do perpendicular and parallel? Okay, so it was in here as well. I did that in my geometry class too. Look at the slopes. Negative 1/2, positive 2. What are they to each other? They're negative what? Reciprocals. I use reciprocal. You could say inverse. It's fine. So they're negative reciprocals of each other. So they're absolutely 100% perpendicular to each other. But that's not what I care about. Okay, what do you think that I care about? I'm trying to solve for x and I'm trying to solve for y. I want to know what x is equal to and I want to know what y is equal to. So remember, these two, well, let's go back to this. These two, it's a system of equations. They relate to each other. They both have the same what? X, and they both have the same what? Y. So take a look at here. The red line and the yellow line. Is there a point that they share, that they have both the same X and the same Y? Absolutely. It's the point of what? Give me a good word. The point of intersection. Okay, it's the point of intersection. So wherever they intersect each other, whatever the ordered pair, whatever the location of that point is, okay, that's my X and my Y. All right, so let's figure out what that point is. Again, accuracy is really important here. So it looks like it crosses right there. So what do? I start here and I go what? 2 and then up 1. So positive 2, positive 1. So my ordered pair is 2, 1. That's actually the way that they want you to write these answers. I put up here x equals y equals, but they want you to write the answer as an ordered pair. If you do an odd problem in the back, right, you look at it to see, right, you do the problem, get an answer, and you look to the back of the book to see if it was correct or not, you will see them that they write the answers as an ordered pair. Does that make any sense? It's pretty simple, isn't it? Yeah, you just graph a couple lines, find out where they intersect, and wherever they intersect, that's your x and your y. So that's my answer right there in that box. It's 2, 1. If I wanted to, I could say, what is the x? The x is 2. What is the y? It's 1. Some people are fine with you keeping the answer like that. Tell you the truth, I probably on a quiz or a test, if you wrote it like that, I probably would not mark it wrong. All right, but you should write it as an ordered pair. Okay, that's the way they want you to write it. Let's write it like that. Okay? Pretty simple, isn't it? Yeah. But you got some weird things that could happen with some of these. Let's take a look at this. So this is example 2. So let's do a couple more graphs. Another system of equations. All right, so it's 2x plus 3y equals 6. By the way, in the next section, I think, we take these same exact equations, these same exact two equations, and we solve them a different method. We either solve it by elimination or we solve it by substitution, okay? And you'll see that if you have it all in your notes, it'd be easy just to flip back in your notes and see what the answer was, okay? So the answer was 2, 1. We're going to do this either tomorrow or the next day. We are going to do it a different method, and we're going to see that is true. All right, enough of that. Let's do this. So that's the first equation. The second one is 4x plus 6y equals 24. Okay? And what we're going to do is we're going to solve it by graphing. All right, so what do we do first? The way it's sitting there right now, can I graph it the way it's sitting right now? No. I want to put it in what? Slope-intercept form. Very good. All right. So I'm going to put in slope-intercept form. So let's do this quickly. I've already shown you once how to do it. We just had a chapter and a test on it where we had to do it. So let's do it kind of quick. So what would I get? 3y equals what? Negative 2x plus 6. It's negative 2x plus 6. Divide by 3. So y equals what? Negative 2/3 x plus 6 divided by 3 is 2. So that's one of the equations. I'll put it in a box. You don't have to put it in a box. I do just so it stands out a little bit, all right? So I know I'm going to graph that. Again, it's not hard to graph. Just because it's got a fraction, we graphed a fraction the last time, didn't we? So it's really not that hard to graph. Let's do the next one. So let's solve for y. So I subtract a 4x from both sides. So I get 6x equals negative 6y equals negative 4x plus 24. Divide both sides by 6. Divide this by 6, I reduce it. That gives me negative 2/3 x. Divide that by 6, I get 4. I did that kind of quick just because of time and because you should know how to do that already. All right, so now what we're going to do is we are going to graph. Now you're going to find something. Well, you should see it actually already. Remember Alex, you're the one that said they're perpendicular, right? And I didn't realize it, but when I looked at it right here, check it out. I got a negative 1/2 and a 2. They're negative reciprocals of each other, so that means they're perpendicular, right? So let's take a look. Alex, what is it? Yeah, they're parallel to each other. Without me even graphing it, you can tell that they're parallel to each other. Why? Why are they parallel to each other? Because they have what? The same slope. Exactly right. They have the same exact slope. All right, so they're parallel to each other. So let's think. I haven't even graphed this thing, and we're thinking about the answer already. If they're parallel to each other, what points do they have in common? Where do they intersect? They don't intersect. So do they have any points in common? No. So what's my solution? There is no solution. Exactly right. That's your solution. You just write no solution. All right, let's graph it though, just because that's what we're doing. Let's go red and yellow. Keep the same color combo going. Let's do this one. Plus 2. Right? That's the y-intercept. The slope is negative 2 over 3, so I go down 2. I run 3. 1, 2, 3. Let's just see if they really do look. Now, I could do some more, be a little more accurate, but again, I'm just trying to save some time here. All right, so that's the first line. Let's do the second line. We'll do that one in yellow. Y-intercept is 4, so 1, 2, 3, 4. It's right there. And the slope is the same exact thing. It's negative 2 over 3. 1, 2, 3. Check it out. These two lines are parallel to each other. So how do I find the solution? By graphing. I find out where they intersect each other. And where are these two lines going to intersect? Never. That's the definition of parallel lines. They never intersect each other. Okay? So they will never intersect. That means there's no x and y that works for this and this. There's no number in the world that you could put in for x and get an answer, and then put that same number in for x right here and get the same answer. Everybody see that? Because think about it. You put a number in for x, you're multiplying it by negative 2/3, right? You put it in here, you multiply negative 2/3. You get whatever you get. But then on this one, you have to add a 2 to that number, and this one, you have to add a 4 to that number. You know they're going to be completely different numbers now, don't you? Right? Because this, putting a number in for this and putting a number in for this, you're going to get the same exact number. But then what are you going to do? You're going to add a 2, you're going to add a 4. That automatically makes this one 2 bigger than this one, right? Because this is plus 4, this is plus 2. So does it make sense in your mind when you kind of manipulate it around a little bit? Yeah, I think it does. Okay, so that has, they call this, they give this a name. Let's write down the, oops, change it to this. Let's write a word down just in case you see it in the book. They call these inconsistent systems. Okay? All right, which means you're not going to get any solution. So what's your answer? What do you write down? You write no solution. All right, and that's your answer right there. All right, good. Let's go to another one. I think this is the last one. Nope, we got 2 more. I'm going to go maybe even faster on this one just because I really want to get to this, the 4th example. This says solve by graphing. So this is a little different. It's just not your normal, everyday, get a ordered pair answer kind of thing. All right, so this is what we are graphing. So let's put it in y-intercept or slope-intercept form. So let's do the first one. Add an x to both sides, divide by 2. Can we do that in our head? I don't know. Divide that by 2, add an x, so that would be what? 1/2 x plus what? Took that 4 divided by 2, I get 2. Yes? All right, you can do the work if you want, show the steps. This one right here, let's get y by itself. Well, y is kind of already by itself, so really all we got to do is do what? Divide both sides by 4, so what do we get? Y equals what? 1/2 x plus what? Plus 2. Check this out. Look, tell me something about these two equations. They're exactly the same. So if I was, I'm not going to do it, okay, but if I was to graph both of those equations on one graph, what's going to happen to those graphs? They're going to be the same exact line, aren't they? So where do they intersect? Where do those two lines intersect? Everywhere on that line. You could say anywhere, but everywhere on that line. So your answer is basically all the numbers. The other one was no numbers. This one, we would say all the, we'll say the real numbers, okay? All the real numbers. Because there are numbers that are not real. Okay, they're called imaginary numbers, so we're sticking with the real numbers. So really, if they're both exactly the same, not just the same slope, but they got the same slope and the same y-intercept, that means they lie directly on top of each other. That means every point on that line, anything you put in for x is going to work. All right? It doesn't matter what you put in. Any real number, if I put it in for this x and I put it in for this x, my y is going to come out to the same exact answer. Makes sense, doesn't it? Yeah, I think so. Let's do one more. This will be the last one, okay? Man, when's the last time we finished a whole entire section in one day? Don't think so. All right, it says solve by graphing again. Now, it's going to introduce a couple things here that I know you're not going to like. And you see it already. What is it? Fractions. But we're going to do something so that we don't have to work with fractions. Right there. You didn't see it? There it is. All right. And we'll put that little brace thing around it. Oops. Maybe try this again. There we go. All right. It's weird looking brace, but it's good enough. So what are we going to do? Put it in what? Slope-intercept form. But I don't like the fractions. Do you? No, we've already established we didn't like the fractions. I'll tell you what, I'm just going to I'm going to copy and paste this because I want to do some stuff with this. I want to keep the original problem there, but I want to mess around with it and do some things to it. All right, so what we're going to do, let's go. I haven't used green today. Let's use green. What we're going to do is we're going to write this so we don't have any fractions. Wouldn't that be a lot better? Absolutely, okay? So what's making this a fraction? Is the 3 making it a fraction? No, this is the 2. It's the denominator that makes it a fraction. You got a 2 here and you got a 2 here. So I want to get rid of the 2. Would you agree? So if I just do the opposite of dividing, which is what? Multiplication, that'll cancel out. But I can't just do that to one of them. I can't even do it to just 2 of them. I got to do it to what? To everything. Not just the fractions, but I got to multiply everything by 2. So I multiply that by 2. I also have to multiply that by 2. And I come over here and I multiply this one by 2. Would you agree algebraically that you're allowed to do this? Yeah, all the rules of algebra says that we can do this. Is it says or say? I don't know. Rules say. The rules say. That's the correct way. What about right here? We'll work with that in a second. All I got to do is get rid of that 2. I still have to multiply everything by 2, though. I got to multiply that by 2, and that by 2. All right, let's see what we get now. So if I multiply, those cancel out. What am I left with on that top equation? 3x. What's this going to be? Minus what? 2y, because I multiplied that y by a 2, equals, what happens here? Cancels out. I'm left with a 5. Now that looks a lot better than what we started with. Would you agree? It's still not in slope-intercept form, but that's okay. We can do that in a minute. All right, let's do this. What do I get here? I got 2x. What happens to these 2's? They cancel out, and I'm left with plus y. What do I do here? Just multiply them together, and that's 8. Now, we're back to the very first example. All right? All we got to do is take these and then just put it in the slope-intercept form, and then we can graph them. Again, the graphing is the easy part, but I want to get to that graph. I don't have a whole lot of time, so I am just going to tell you what this is. I'm not going to do all the steps. So this first one is y equals 3. You can do the steps to make sure you get to this. All right, and then the second one is this. Now, this does introduce something a little weird. Oops, I don't want that. Let me go back and get my graph. Come on. Just use the arrows. All right, here we go. Let's use a couple different colors to do this. Let's use red first. We got to do, yeah, we can do this. So let's do the easy one first. This is negative 2x plus 8. Do I have 8 places? 1, 2, 3, 4, 5, 6, 7. Yeah, perfect. So it hits right there. It's the y-intercept, negative 2 over 1. And if I wanted negative 2 over 1, I'm going to do this for a reason. Negative 2 over 1, negative 2 over 1. It doesn't take that long to make that a little bit more accurate. Agreed? So there's the one line. Now let's do the other one. Now the other one's a little weird. I don't think you've seen this before, but look, we're going to graph this. What in the world is that? Negative 5 halves. What did we do with that? It's negative 2.5. Exactly right. Okay, so you just change it to a mixed number. It's negative 2.5. So I got to go down here to 1, 2, and what? A half. Right there. So I put it halfway. Now what's my slope? It's not negative. It's positive 3 over 2. So I got to start at the halfway point right here. And then I got to go up 3. So where's that going to put me? I'm going to be in between each one of these, aren't I? Because I'm going up 1 full. So there's 1, there's 2, there's 3 right there. And then I run how far? 1, 2. So it's right there. Okay? It is weird. This is where accuracy is super important. All right? So now, I'll tell you what, let's do this. Let's start here and do the slope. So I go up what? 1, 2, 3, right? Halfway, and over what? 2. So I did not draw something very accurate. 1. Oh, yeah, I did. Yeah, I'm fine. All right? Just to make sure that I'm pretty close. Now, these do intersect each other, don't they? Where do they intersect each other?
When the bell rings at the fountain,
they intersect each other right there. And I got to find that point. So I start here and I go 1, 2, 3, 1, 2. So my solution is 3, 2. That's my answer right there. Do you see why it's very important to be accurate on this? If you're just slopping lines and points all around the place, you're not going to come close. All right? All right. That's all I got. So you do have a homework assignment. Look, I gave you the lesson plans. It's 15 to 24 on this section, okay? 15 to 24. That is due tomorrow, all right? And it's section 3.1. Yeah, this is called 3.1a, by the way, because that substitution elimination is actually part of 3.1, okay? So that, why is everybody leaving? Bell didn't ring, did it? You leave when I dismiss. Have a seat till the bell rings.